In this video, we're going to do the following problem. And actually, the statement of the problem is pretty long because first it tells us about a formula that we're going to use, and then the actual problem comes. So let's first read that statement about the formula. If a firm invests P sub 0 at an interest rate of R%, then 1 year later invests P1 at the same interest rate, then at the end of 2 years, the total amount A is given by A is equal to P sub 0 times 1 plus R squared plus P1 times 1 plus R. So looking at this formula, the first part here shows us the amount that we would get by investing some amount at R% for 2 years. That's why we're squaring there. And then the second part here is what we get by investing that second amount for only 1 year. So now comes the actual problem that's stated on MyMathLab. A firm invests $5,000, then 1 year later invests an additional $1,500. At the end of 2 years, it has a total of $7,452. What is the interest rate? So let me do that so that we can still see that formula at the top. We're going to go ahead and substitute the information we're given into the formula. So we're going to have 7,452 is going to be equal to the first amount invested, which is 5,000 times 1 plus R squared. And we're being asked to find the interest rate, so it makes sense that R would be a variable that we'd leave in the equation. And then we're going to add to that 1,500 times 1 plus R. Okay, so this is the equation we want to solve. And we want to solve this for R. So the first thing we're going to do is we're going to multiply out that binomial 1 plus R squared. And that's going to give us 1 plus 2R plus R squared. And we're still going to be adding on 1,500 times 1 plus R. And in the next step, we're going to distribute to get rid of those parentheses. So that's going to give us 5,000 plus 10,000 R plus 5,000 R squared plus 1,500 plus 1,500 R. And now we're going to combine like terms. So we're going to get 7,452 is equal to, and we're going to put this in the order we like to see quadratics in. So we're going to start off with 5,000 R squared. So that takes care of that term. And now we need to add together the two terms with R in them, which are this one and this one. So if we add together the 10,000 plus the 1,500, we'll end up with 11,500 R. And then lastly, we have the two constant terms that don't have any factor of R in them. And when we add those together, 5,000 plus 1,500 gives us 6,500. So now we have the equation 7,452 is equal to 5,000 R squared plus 11,500 R plus 6,500. And in order to solve this, we are going to subtract 7,452 from both sides of the equation. And when we do that, we're going to get 5,000 R squared plus 11,500 R minus 9,048. And now in order to solve this, we're going to use the quadratic formula. So we need to identify A, B, and C. A is going to be equal to 5,000. B is going to be equal to 11,500. And C is going to be equal to negative 948. So R is going to be equal to negative B, we'll just write out the formula first, plus or minus the square root of B squared minus 4AC all over 2A. And as we substitute in the values, we're going to get R is equal to negative 11,500 plus or minus the square root of 11,500 squared minus 4 times A, which is 5,000, times C, which is negative 948, and that's all going to be divided by 2 times 5,000. Now I'm going to use my calculator and plug in some numbers to simplify this a little bit more. I know that 2 times 5,000 is going to give me 10,000, so that's going to be my denominator. But now to find out the value of the discriminant, that is the part that goes under the square root, I'm going to use my calculator. So I get 11,500, and I'm going to square that, and I'm going to subtract from that 4 times 5,000 times negative 948, and that gives me 151,210,000. And actually I just noticed that there's a mistake up there, so I'm going to go and sneak that 0 back in up there. And now thinking about the next step, I'm going to want to evaluate this all on my calculator in one step, the next part of it. But looking at this and this, I can see that if I do a subtraction, then I'm going to end up with a negative result. So negative 11,500 minus the square root of, I'm just going to put blah here for now, divided by 10,000 is going to be equal to a negative value, and that's not going to make sense in our context. So we're going to be able to ignore that result. And instead, the one that's going to give us the value that we're interested in is going to be negative 11,500 plus the square root of 151,210,000 divided by 10,000. So just be a little bit careful when you put this in on your calculator. Make sure you put parentheses around the numerator. And when I stick this in on my calculator, negative 11,500 plus the square root of 151,210,000. So I'm using a set of parentheses to close the square root and another one around the numerator, and then that's going to be divided by 10,000. And the result I get is that R is equal to 0.0796. And this is the decimal form of the percentage. So that means that we would have to multiply this by 100 to get the percentage form. So the percentage form would be 7.96%. So this is the percent form. And if we read the instructions for entering our answer, they say that we should enter the nearest whole number. So if we round this to the nearest whole number, we'll get 8%. So that's the answer that we're going to enter. And that's the final answer for our problem. So if the company is investing, the way it's described here, $5,000 for 2 years and then $1,500 for an additional 1 year, and has $7,452 at the end of that time period, then the interest rate that they're investing at is 8%. I hope you found this helpful.